All right. So if you look at it, it says which line has a slope of 1. So if you, first of all, one thing we need to notice about this diagram, don't all the lines go through the origin 0, 0. So we can always start counting at the origin. So if you put your pencil tip down on the origin, if you think about slope, isn't it rise over run?
Rise 0, run 0.
Well, for 1, you would rise 1, and remember, if you don't have a denominator, you can always stick it over 1, because 1 over 1 is the same thing as 1. So if you rise 1 and run 1, what line do you hit here?
Rise 1, depending on which way you run.
Well, remember, to the right is positive. If it were negative, you would go left. So if we go, well, we go right. So it is H, okay? Everybody hitting line H? Rise 1, run 1, okay? So you'd hit line H there. Okay, now which line has a slope of -1? So let me put, on 2, let me put -1, and again, I don't have a denominator, and I need 1 to think rise over run, so I'll just stick it over 1.
I like these.
So down 1 to the left 1, if you color in a dot there, what line have you hit? Oh, wait, I messed up. Yeah, it's down 1, right 1, and I'm just, my brain, you're going to see today, my brain and my mouth are not working together. Down 1 to the right 1, yes, I did it wrong. C, correct.
Yes.
Okay. Now, which line has a slope of 0? What kind of lines have slope of 0?
X. They're like that.
Well, it's y equal, but it's a flat line, okay? So you're doing the right direction, but that equation would look like y equals something. Now, what's confusing, though, is what line where's there a flat horizontal line?
There's not. There's X.
The x-axis, okay? So we're just going to write x. We're just going to call it x because they kind of are trying to mess with you a little bit there. You're thinking, surely they don't mean that, but they do, okay? Which line has a slope that's undefined?
Y.
The y-axis. Yeah, the y-axis. Y. Good. Yeah. And that equation, even though it's the y-axis, the equation is x equals 0 in this case, right? Isn't that why this is so confusing? Horizontal lines are y equal, but like in this case we see that's like the x-axis in this picture, and like or it's something that would be parallel to the x-axis. So it's a little bit counterintuitive, isn't it? Which line appears to be perpendicular to line J? Yeah, I would say D. What do y'all think?
I said this line is a line.
Did you say E?
I said E because line J is like right next to the x-axis, and line E is right next to the y.
How could we know for sure? Check their slope. So let's see. For J, the slope was rise 1, and if you look, if you run out over 4. Okay, so J has a slope of 1, 4. We need the line that has a slope of -4 over 1 would be perpendicular. I flip the fraction and I change the sign. There's two things to remember, right? And y'all, those of you who've turned in your work so far have done a good job of remembering it. But I had a lot of papers that from yesterday that were not. They had forgotten that one little piece. Okay, so if we start at the origin and we go down 4 to the right 1, that line did end up being E, isn't it? So can we go by what it looks like sometimes? No, the safe way to do it is to count it off, count the slope off. So it is line E. Let's see. So that's number 5. The answer is E. So what are the slopes of line J in that line? Okay, so they were asking you really, in 5, they were like, eyeball it and tell me what you think. And then on 6, basically they're saying count it, and that's what we just did, right? So so we had a slope of 1/4, and we had a slope of -4, didn't we? Okay, so let's learn from that. And on number 7, if you eyeball it, which line looks like it's perpendicular to B?
G.
Okay, so you might have a different answer because remember we're all looking and we're eyeballing it. So maybe we think it's G. And now we're going to find out for sure if it is, right? By counting it. That's what number 8 is asking for. The slope of B.
Oh, I'm on number 7.
Yeah, we're on number 7.
Oh, we are, so I said the right thing. Okay.
Yeah, you were on that one. Yeah. Yeah, so we're eyeballing it. Looks like G. Let's count on 8. They're saying what is the slope of basically line G and line B. Well, line B had a slope of, didn't we do that one already? Let's see.
No.
Let's see, where is B? I can't even find it. Let's see, rise. Ooh, B's kind of weird, isn't it? Here's how you could count B. Look up here. Let me use a different color so you can see where I'm marking it. Do you see that B is on right at a crosshair of one of those things there? And it's over at also at a crosshair right here. So you can count between those 2 points if it's easier. For me, that's easier than to try to do some of the other ones that I see there. So that would be rise 1, run -2. So -1/2 would be B. So B, the slope of B. Here's how we could write that. M means slope, and little b there just means we're talking about the slope of line B. That's all that really means when you see stuff that looks like that. So that was, I already forgot it, -1/2, right? Does it matter whether I put the negative on top, bottom, or like lined up with the fraction bar? No, it's it doesn't matter. I just have to make sure I only write it once, right? Okay. And here's why. If I were to put it on the top, we counted it off 2 left, didn't we? But if I were to count it, on the top part, it would be down 1 to the right 2. Do you see that I'm still ending up on the same line? If you move that negative around, it'll just help you get points on the other side of the point you started with. So if you ever, if you didn't know that, that might be something good to know. Line G, let me pick a different color because there's getting... It should be, or 2-1. It should be 2-1. So let's check and make sure it is. Here, if I start at the origin, up 2 over 1. Yeah, G is 2 over 1. So they were perpendicular. So here's something just to know. You could put equations of lines on your calculator at the y equals, You could put a whole bunch of lines there. And if we had the same thing on the calculator and we tried to look and eyeball it, you probably would get it wrong because this screen, just the way, I don't understand, some of you probably can figure this out a whole lot better than I can, but just the way it looks, it's like squared off or something. They've done something to kind of make it look square, where in parts it throws some stuff off. I don't understand what's going on with the screen on your calculator. Perpendicular lines don't look very perpendicular, so that's why it's always safe to look at the equation more, or to actually, if you can see to count it off, it's safer to do that than to eyeball it on a calculator screen. It never works very well on these graphing calculators. All right, 9, state the theorem illustrated by your answers to exercise 5 through 8. So which one do you think they're talking about? If you look in this section, we got theorem 52 and 53. 53, yeah. Now, did we take those slopes and multiply them to get -1? Is that what we really did? That wasn't what I was thinking. But if you take a fraction and you take its reciprocal and you have one positive and one negative, don't they multiply to give you -1? Right? The theorem is stated that way, but honestly, guys, I never think that way. So if you want to think that way, you can. I always just translate that to there's 2 things that make them perpendicular. They're flipped fractions of each other and they're opposite signs of each other. So you always have one positive and one negative. That one's hard to remember because there's 2 pieces to it, and it's easy to forget. Okay, so that's actually theorem 53. I'll just write on top of the thing here. Okay, can you find any lines named with letters in the figure that have the same slope? Y'all see anything that has the same slope? Yeah, that's just a trick question. There aren't any, are there? The problem says basically most snow avalanches start on slopes inclined between these 2 degrees, 30 degrees and 45 degrees. Use your calculator to show that snow inclined at an angle of 30 degrees has a slope of 0.58. So they're telling you, you got a slope of 0.58, and if you're talking about the slope, if this is a mountain, this is the slope they're talking about on this one, right? The black line. And then over here, wouldn't the slope on a mountain be that, right? They're just taking they're imagining that this is like a piece of a mountain or something. Like you could complete it out like that if you wanted to really represent it like a mountain. How can I know anything about what that slope would be when they haven't told me any of the rise over run so I can count it? Or do I know something about the sides? What did we do with these? Y'all already said it. Didn't we label them? So let's go label them. And I'm going to use red for that because we can use the labels we know to calculate this slope here. Because slope is the same thing as the tangent of an angle in the triangle, okay? It would be the same thing as the tangent of this angle right here. So if I label these, I'll have things that will help me out here. I don't know if y'all remember I mentioned that, and they kind of played around with it a little bit in 11.4, but now they're just kind of actually trying to get you to full-on see it, okay? So opposite the 30 degrees, I'll label it, we'll just call it X this time, okay? Opposite the 60-degree angles, that would be, I remember that one, it was X times the square root of 3, and across from the 90-degree angle, what was that one? 2A, 2X, whatever variable you use, right? Okay, so if I want to know the slope here, the slope is the same thing as the tangent of that 30 degrees. Well, if I want to put this in my calculator, let's first get a fraction that we can divide out, okay? Isn't tangent the opposite side? Remember SOHCAHTOA? Tangent is TOA. Tangent is opposite over adjacent, isn't it? And my opposite side is X. What's my adjacent side? Now, I'm going to do one little thing here just to try to, have a number when we're left over. These X's are going to cancel out, aren't they? So I need a number on the top. Isn't X the same thing as 1X? So let me put the 1 in there, because when I cross out those X's, because they cancel out, I get 1 divided by the square root of 3. So now in your calculator, do 1 divided by the square root of 3 first. So just put in 1 divided by square root 3. If you don't have a calculator, I have another scientific one here that you can use if you need to borrow one. This is what I'm going to get. I'm going to write it out for a couple of digits past where they are doing it. They say it's supposed to be 0.58. Doesn't this 7 right here round this 7 up to 0.58? Is that what y'all are getting, 0.57735? It kind of broke off towards the end because the iPad doesn't pick up over there very well. Now, I also could do this. I want you to do this. We did that off those, if you think about it, isn't the opposite, if I'm looking at that black line there, and I'm trying to get from this point to this point, wouldn't the rise here be the same as the slope of the thing across from it? This side over here that's X? Because it's going up, isn't it? And it's parallel to my rise. So there's the rise, and then the run over would be parallel to X squared of 3. I could make a little rectangle out of that and say, oh, if that's X, this is X. If this is X squared of 3, then this one I'll highlight in yellow since I don't think I can write up there. This right here would also be X squared of 3 because we've made a little rectangle here. So do you see that the rise over the run is X over X squared of 3? If I draw a rectangle in there, you can really easily see it. Now I want you to hit mode on your calculator. Make sure that you're working in degrees because like mine was set on radians, so yours might be 2. So it's either mode and then just space over to degree and hit enter. Remember second quit to get out of it on the graphing calculators. Maybe you could get out of it with, you probably have to hit shift mode or something, right? Or something in your scientific calculator. Now, I want you to go back to the home screen, which you would hit second quit in a graphing calculator, and type in tan 30. If I type in tangent 30, just straight into the calculator, what do you see that I'm getting? Same thing, right? So do you see now that the tangent and the rise over run, they are the same thing, aren't they? So we can always, if we know an angle, we can find the slope by taking the tangent of that angle, and you wouldn't even have to count rise over run. You could just go tan 30 in your calculator, and you'd have the slope of an angle if it's set up like this. And most of the times you do have a horizontal line and an angle given in relation to that horizontal line. So the fact that we might get that 30-degree angle is pretty normal in working, with even real life problems.